Welcome programmers, welcome music lovers, welcome to Code and Coda. Thank you for joining us this evening. We are streaming live from Boston, Massachusetts. Just as we are every Sunday evening. Sorry we were offline last weekend. But we are back this weekend. My name is Joseph Parzell. I am a software developer and an app publisher. My friend on guitar this evening is Eric Gaudet. Here we go. Welcome to Code and Coda. This is season 1 of Code and Coda, and we are now in episode number 5. Episode 5 is Response Continued. We are going to take over where we left off from last time, and finish creating a response to send back to Alexa from our web application. Here is our technical specification for episode 5. We will, of course, start off with a quick introduction to Code and Coda, and then after the introduction, we will try to get through last week's slides in less than 5 minutes. That's always fun. And continuing on from last episode, we will work within our development environment, but more specifically, we will continue working on our asynchronous function. And before we're finished, we will have created a new class in our web application which will contain our response object. Don't forget, YouTube chat is open tonight, so if you want to just say hi, or if you have a question, comment, or suggestion during tonight's episode, feel free to send us a chat. We'll try and respond live on air. So, quickly, an introduction to Code and Coda. Well, this was a Teams Thursday New England presentation, and unfortunately, Teams Thursday was canceled, so I took my slides and asked my friend Eric to play some guitar while I presented these slides online. Here you can see a few more reasons why we love Code and Coda, and as my friend Jim Wilcox, the Granite State hacker, put it, the cool kids watch it live for the awesome code tips, cooler kids join for the music, and the coolest kids dig it for both. So, I've promised last time that I would have a couple reminder slides here. The first one is that we do have a special guest with us this evening. And if you also have an Alexa device within earshot of Code and Coda, then I suggest you press the mute microphone button on your Alexa device for today's episode. Why don't we introduce our special guest, Alexa, see how she's doing this evening. Alexa, how are you doing tonight?
You caught me in the middle of doing the hokey pokey, so I'm all turned around.
Weren't you doing that last time, Alexa? Alright, how about this? Alexa, why don't you tell us a music joke?
Sorry, I don't know that.
I know you can do this.
If you have a minute, I can show you a few things I can do.
Alright,
Do
let's
you
try
want to
this
hear
one more
more?
time. Alexa, please give us a music joke. You did this
What's
before.
Cupid's favorite rock band? Kiss.
Cupid's favorite rock band is Kiss. Alright, let's move on from this. One quick note, we do have a fireworks advisory this evening. Yes, in the town of Boston, people have been shooting off fireworks left and right for the past few weeks, so if you hear a loud boom or some fireworks in the background, our apologies. People have been going nuts. All right. Well, before we get to our recap from last week, why don't we take one quick look back in at our friend Eric, see how he's doing. Thank you, Eric. Thank you, of course. Sounds just great. I should make a note that for this week's episode of Code and Coda, we're trying something new. You may know this already. We are using Microsoft Teams to broadcast audio and video. But for this week, we've decided to try a combination of StreamYard for audio and Microsoft Teams for video. The goal was just to try and get a nicer quality audio sound here, and with StreamYard you're able to disable the audio processing. So we're giving it a shot for this week's episode. I hope it sounds a little bit better for you. Alright, so recap from last week, we did update our JSON data object with some new fields. Remember, we have the API URL and the device ID and some other pieces of information that Alexa is sending us in the request. And we're able to decipher the type of request that's sent to us. Without further ado, how about we just go ahead and get started with our recap from last week. We are going to do this in 5 minutes or less, and with the help of Alexa, I'm going to go ahead and start a countdown timer. Let's see if Alexa can do a timer for 5,000 milliseconds. Alexa, set timer 5,000 milliseconds.
Timer for how long?
5,000 milliseconds.
Timer for how long?
5 minutes, please.
5 minutes, starting now.
Alright, starting now. Here we go. Last week's recap. So we continued in our development environment and we went through the process of debugging our web application, set some breakpoints and did all that. Here's our slides. So we can take a look and remember that in our web application, the get page, we have a button that we press to run some JavaScript. Here's the JavaScript that we're running. There's our post data object, and this post data object we updated with some variables and some more information. Where did we get that information from? Well, we can go back to our testing console and get that data from the response JSON that Alexa sends, like the application ID, the device ID, the API endpoint, access token. So we're hard coding some of those values because some of those values will not be changing, but what we would like to do is have some of those values be more dynamic. And if you see here, one of those values that's dynamic is the request type. We're sending that via the button. But what we also want to be dynamic is the API access token. Now here you can see we've set a breakpoint in our JavaScript, and that is showing us that our launch request is being sent. If we want to see what else is in that data object, we can send it to the console, which we did there. And on the right hand side, we didn't quite send it correctly. We are getting an object in return, so we added the JSON stringify method to our console log line of code there. Back to our HTML file, what we did was we added another field. It's a text area input, which will be our API access token. That allows us to submit an API access token on the fly because that access token changes every 15 minutes or so. Where do we put that API access token? Well, we put that in our post data object, but I made a mistake last week. It goes in postdata.context.system.api access token. We'll look at that a little bit more later. And you can see down here, I just kind of made that change just to show you that was not in last week's slides. And where do we get the API access token? Well, let's go back to the testing console and we get our access token. There's the old access token. When we hit refresh, however, we get a new access token. Like I said, about every 15 minutes you want to do that. We put the access token in our new text area field there, and on the right hand side you can see the request that we send via JavaScript and the response that is created. The next step that we went through last week is we started creating asynchronous functions. So the first thing we did after minimizing and collapsing all of our functions is we went into the HTTP post index method and set that to an async method, which also forced us to change the return type to a task return type. We also need to place an await operator within our code block. So what we did was we created a new function called getGreeting, and we just said, hey, let's await that function. We generated the getGreeting function automatically using IntelliSense and then went ahead and changed that to an asynchronous function, return a task of type string, and then within that we also added some other code here, which you can see. The asynchronous code that we want to run is going to be an API call to the Amazon Alexa API. And unfortunately, when we run the code, we get an error. We don't know what our error is. So what we did in our code is we ended up putting in a try catch block. And when we get an error, we return the message as an error message. We go ahead and run our code one more time, but before we do that, we have to add our error message to the end there. And finally, when we run it, we get the error message invalid URI, and that is where we left off from last week. Just to know, you can also set a breakpoint and you will get the same error message, and that was last week's slides within 5 minutes. If you want to read more about the API endpoints from Amazon Alexa, the documentation is very good. All right, great. Just in time, 5 minutes. Alexa, stop timer. Well, that is the end of the recap. So, of course, we are going to do some garbage collection and dispose of our recap. Part 1 is coming up right now. But first, why don't we take one more quick peek in and see how Eric is doing. cheers, of course, to my fellow coffee drinkers out there. I should also probably say hello real quick to my friends all the way down in South Carolina. I think they are watching with us tonight. So hello, friends down in South Carolina. Hello, Max. Hello, Evie. And hello, Mary Raiden. Thanks for watching. I think there's a few people in Connecticut watching tonight too. Some people from New Hampshire. All right, part one, here we go. What are we going to be doing here? Well, we're going to update our getGreeting function. Remember, our getGreeting function... Oh, sorry. Before we get to that, let me just show you. We're going to update our getGreeting function and add a URL, or multiple URLs kind of, to that function. Remember, we got that invalid URI error last time. Where do we get this? Where do we get this information? Where do we get that URL? Well, Alexa sends us that URL in the request. So it's all in that JSON, and we're going to parse through that JSON to get that data. So here you can see in our development environment, we're setting up our request to include some of that information. Back to our C# home controller and our getGreeting function. And you can see from last week, this is how it looked last week. We did not put any valid data into those methods there, but what we're trying to do here is basically send an API request to the Amazon Alexa server. We're doing that using an HTTP client object, and we're calling the getAsync method to get data from another server. And the data that we're going to get is going to be data that tells us information about the Alexa device. And the first thing I'm doing here in our C# is I'm creating some variables. Now keep in mind, while you're looking through this code, you can look at the line numbers, and also next to the line numbers you can see the green coloring just lets you know that this is new code added to the file since the last time we had the solution open. So I'm creating a couple variables here in C#, namely API endpoint, API access token, API time zone URL, and device ID. The only one that we are going to hardcode here is the time zone URL, and this is the URL that we get from the Amazon documentation. This is the API endpoint that will tell us what time zone the Alexa device is in. Those other values we're going to get from the JSON request that is sent to our web application. Where does that JSON request end up? Well, when that data is posted to our web application, this HTTP post method of the index view has the request sent to it, and if you remember, we went through and started parsing this JSON data to get specific fields out of that request object. Now, we did go through some data validation methods here. You can see we're checking the value kind property of the root element of the JSON document object. Now, since we're fairly certain our data from Alexa is not going to be bad, I've just gone ahead and cleaned out that data validation and made it a lot simpler to view. So you can see all we're doing is we're taking our Alexa post request, that's the data that's sent by Alexa, and we're creating two main variables there, the context variable and the request variable, and within each of those are the fields that we need. So to continue on parsing through that information, we just add a few more try get property methods and keep digging through all of that JSON data until we get the values that we're looking for, like API endpoint, API access token, device ID. And what we're doing here now is we're going to go ahead, we click the run button of our web application and we're going to run a test, but for our API access token, we're just going to put in some gibberish there just as a test. And I should back up one slide. What I did do is I set a breakpoint on line 61. So, or maybe, excuse me, on line 75 here. And so this breakpoint is within our getGreeting method. So just take one step back here. I ran our web application. This is the get page of our web application. I put in a bogus API access token, and we got an error when we tried to access the Amazon Alexa API, and that is because we're not using a valid access token. How do we get a valid access token? Well, we can go to our Amazon developer console, type in our invocation phrase code in Coda, which creates a request object here. Within that request object, you can see the API access token, so we can just copy it from here. Paste it into the text box, and when you run it again, you can see now we get an OK status. And I might have skipped over one slide here, but just so you can see, what we did was after we set the variables in our index method, the device ID, the API endpoint, in our getGreeting function, we took those values and placed them into our other methods down here so that we could access the data from the Amazon API endpoint. Sorry, I kind of breezed over that part a little bit too quickly. But here you can see we're now getting a response from the Amazon Alexa server. Within that response is the time zone of the device that sent the request. In the next part, we'll go through and parse the JSON that we got from the API endpoint from the Amazon servers, and we'll see what the time zone information looks like, and that'll come up next in part 2. Let's enjoy Eric for a little bit here. going to take one quick step back. Again, what we're looking at here is the post method of our web application. Within this post method, we are parsing all of the JSON data, and we're setting some global variables like API endpoint, API access token, and device ID. We're setting those variables to the values that we are retrieving as we parse through the JSON object. And after we get that data, we can now use it here in our getGreeting function. So you can see we're now using the API endpoint, the API access token, and one more thing we did up here is we're configuring our URL that we're sending to the Amazon API servers by taking the time zone URL and replacing the little placeholder with the actual data. So if you're having a little trouble following along in this code, I know it's kind of hard sometimes to read through this code as I'm presenting probably. And what I would suggest is if you can always go back and check out the videos on YouTube. All of these are available after the live broadcast. I know some people like to go back during the week and just put this on in the background and listen to the music. And so hopefully some of this does get absorbed. All right, let's skip over to now part 2. And in part 2, what we're going to be doing is some more C# coding here, and rather than hard code our response to Alexa, we sort of hard coded the text in the HTML file. What we're going to do is create a new class and a new C# object for that data, and then send that entire object to the UI layer rather than try and hard code each piece of information. Let's see what that looks like. Now remember, we left off with the access denied, and then we went in and put in our correct access token, the current access token, and what we get in return from the Amazon API servers is this tiny little piece of information. Basically, this is the time zone that the Amazon Alexa device resides in. And this lets you know what time it is, where the user is currently using the device. So it helps you create a localized response. And after publishing our web application, we can see what this looks like back on our testing console. You see now when we type in the invocation phrase code in Coda, we do get the time zone returned to us. So it is a way to send a localized response to the user. Now, what we're sending here is probably not ideal, what you want to send to the user. So if you would like to send a nicer response, like something like good morning or good evening, you can find the local time and convert this data using some more C# libraries that I've used. And these libraries are .NET Core 3.1 compatible. One library, system.timezoneinfo, that comes from Microsoft, but the tzconvert library that was created by a gentleman named Matt Johnson, which is available as a NuGet package. You can read about the time zone database on Wikipedia, of course. Now, like I was saying before, we are going to create a new class within our web application. So, in our models folder, I'm right-clicking on the models folder, and just like the Alexa Post Request class, I'm going to create a new class and call it Alexa Post Response. And that's just a class file. And I'm going to click on Add. Here we are with the default code that comes within creating a new class. We have our post response class here now in our models folder. And what do we need this object to look like? What should it contain? Well, if we go back to our testing console on the Amazon dashboard, here is what the response object looks like. Now you can ignore the body wrapper there. What we're concerned with, at a minimum, is the version and response properties. So, back in our C#. Oh, and just another reminder that this is actually hard-coded into our HTML file, and this is what we're trying to undo right here. We don't want this to be hard-coded. We want to work with this data on the C# end. So back to C# and our response object. What I've done is I've created two properties there, a version and a response. The version is of type string, but the response is an object. It contains properties within it. So let's take a look at that one step back. You can see the version is a string, but the response property contains objects and properties within it. So in our C#, the way that we can represent that is just by creating a new class within the class. And it does seem like the name is a little bit funky there, but our Alexa Post Response has an object called response within it, so that object is an Alexa Post Response response. So we create that object, and then within that response object we have another object called output speech and a property called should end session. You might remember that from a previous episode. That is a true or false Boolean property. And I can show you back one step. Within our response object, you see we have an output speech object and a should end session property. So within our output speech object, we have two strings, type and SSML. Now, before we were using just plain text, but moving forward, we will be sending all responses in SSML language, which is very similar to HTML. We'll get into that. But it's still a string, just has a different name. So here's what our response object looks like. And when we come back to our index, the HTTP post method of our index view, we can add the Alexa Post Response object as a new variable. You can see that on line 60. So we're creating a new variable using that class we just created. We set the version just to a string, 1.0. And then what we need to do for each object or sub-object, we need to create a new object for each of those sub-objects. So you can see on line 63, we create one of those new Alexa post response object, and then on line 66 we create Alexa output speech object. If you're ever unsure what properties reside within those new objects you just created, of course IntelliSense will know, and you can see IntelliSense is telling us we need an SSML property and a type property set here. So we go ahead and set those to a type of SSML, but for the SSML property, the actual text that Alexa is going to say, we're going to set that up a little bit differently. We're going to create a variable called speak. And on line 69, you can see variable called speak. I've added some SSML in there, and that's what that less than is. That's basically creating a tag, and the tag is an Amazon tag, and then the method within the Amazon tag is an emotion. So here we've created a speak variable, and we'll get right back to this. I'll show you this one more time. We're just about to start part 3. And we can see Eric is about to start a new song, so let's say hi to Eric one more time before we start part 3. I hope it sounds a little bit better this week. I feel like it does. And I also think that the video quality on Teams may have gone up a little bit on Eric's end. Since we've muted Eric's microphone in Teams, we're getting sound from Eric via StreamYard now. Seems to be going pretty well. Well, here we are back in our C# code. Remember, we're creating a variable called speak here, and basically it's just allowing us to add some SSML. You can see we're adding an emotion here. So now when Alexa says this phrase, "Hello world," Alexa will say it in an excited tone at high intensity. And of course you need to close your tag there. So after we add some SSML, we're just going to go ahead and add our request type and our greeting to the string, just for the heck of it. And once we create our speak variable, once that's done, we're going to add that to the SSML property of the output speech object, but we do need to wrap that in a speak tag. So any SSML that you want to send back to Alexa needs to be wrapped in a speak tag, and then Alexa will say everything between those two tags. So that's just kind of how I like to set up that variable when I'm returning speech. Alright, part 3. This will be real quick. All we're going to be doing now is we're going to get away from the C# web application. We're going to jump back to the developer console and create a custom intent, which will help us get started for the next episodes to come. Now, I know I said we were going to jump away from the C#, but before we do that, I do need to show you one more thing with this response object. The way to get it to the UI layer. Remember, we're trying to remove the hard-coded JSON that we have in the UI layer. The way to do that is we create a variable and we just call it JSON response. And what we're going to do is serialize our Alexa post response object. Add that to our view data object, which can be accessed in our UI layer. And you can see here at the top, I've created another variable called JSON response, which gets that from the view data object. And the way to display that, now you can see we don't have all of that JSON text hard-coded here. All we do is display the raw HTML of the JSON response. When we run our web application, we put in the correct access token there, and our response now, you can see the SSML. The hello world now is said in an excited tone in high intensity. So we publish those changes to our web application. That way we can see those changes when we run this testing console. Within our developer console here, on the Alexa skill, we are going to add an intent. So right now, the way that we control our Alexa skill is by the invocation, which is code in Coda. And we have one default intent that we've been using called help. Now we're going to create our own custom intent, so you click on intents and add intent. You can give it a name. And here is a little tease for the next episode. What we're doing here is creating an intent called get teams. And when we say an utterance associated with this intent, the get teams intent request will be sent to our web application, and our web application will know that we are looking to get a list of teams, so we will have to send a list of teams back to the user. The way we can do that is using Graph API, and that will be our next set of episodes. But first, after we create this custom intent, we tell the Alexa skill what the user might say to fire off this intent. Of course, one thing the user might say to fire off the intent is get teams. So you type the utterance get teams in there and press enter. You can add some other utterances there that you think the user might say when they want a list of their teams. This could be an endless list of utterances. They do allow you to import and export the utterances that you have for this intent. And I do believe that Alexa would be smart enough to know that if you said, get my list of teams, that would be very similar to these utterances and would be smart enough to fire off this intent. Now, after you create your custom intent, you go to the top and you click on save and build, and so once that's done, you see we have a successful build. Let's go test. Alright, so our invocation phrase, code and coda, we are getting the response, hello world, it's a launch request, and we get our time zone returned when we type the word help. It says hello world, and it tells us we're trying an intent request and what time zone we're in. And when we type in the utterance, get my teams, well, unfortunately, it didn't work. Something went wrong, and now we have to debug. We have to find out what happened. But we can't. Not this episode. We don't have enough time. That's the end for today. But in the next episode, we will debug what went wrong there. And we will also start looking into the Graph API, the Microsoft Graph API. We will be calling the Graph API from our web application to get data from Microsoft Teams to send that data back to the user. And of course, what we want to be able to do is return a list of posts from a conversation. We're getting closer. This was episode 5 of Code and Coda. Next week will be episode 6, Graph, part 1, you can see there. Definitely would like to say thank you to everybody who's joined us from all around the country. And we hope you enjoy the music, hope you enjoy the gong, and hope you enjoy the slides. Maybe learn a thing or two about C#, some JavaScript. And next week we will back at it. We will be back at it with some more Code and Coda. Doors open 9:15 p.m. For now, thanks again. See y'all next week.